In our last video, we looked at differentiating a function multiple times. Now we're going to be looking at the nature of that and actually visualizing it in some way. And to do that, I'm just going to go through some explanations to help you think about this and what we're doing. And then we're going to go into the mathematics side, and then towards the end of our videos of this section, it'll kind of come together. But just to get you in the idea of why we're learning this and what it relates to, differentiation is the instantaneous rate of change. That is the rate of change at any time. Okay, so if an object is moving or changing and its nature of that object is moving in a particular way or shape, or the rate at which it is slowing down or speeding up, that's going to be its differentiation. Okay, so let's go to an example that we can all understand. If we have a car, okay, this car is traveling at 60 kilometers an hour, okay, and it is just on 60. It is not changing from 60, it is not speeding up from 60, it is not slowing down from 60. Its speed, therefore, would be 60 kilometers per hour. That's fine. Its acceleration would be 0. Okay? Its change in speed would be 0. Okay, so if we're thinking about going into second derivatives, what we're going to look at, if, let's just say this is what the speed is, the change in speed is not changing. Okay? Hopefully that helps you understand. If we're looking at a racing car, let's say that can get also to 60 kilometers an hour, but let's say our little Volkswagen here, let's say it takes, I don't know, 8 seconds to get to 60 kilometers an hour. From 0 to 60 kilometers, it takes 8 seconds, like real slow. This sports car, or fast car, whatever you want to call it, it typically can get to 60 kilometers in maybe 1 to 2 seconds, which is incredibly fast. So both cars can get to 60 kilometers an hour. However, the rate and acceleration at which they can get there will differ dramatically. So this car is a lot more powerful and can get to 60 kilometers a lot quicker. Both cars can get there, but this one's acceleration is going to be a lot better. Another example, golf balls, tennis balls. I guess, let's just say you're hitting a golf ball or a tennis ball. If you are hitting it, it's going to be traveling through the air, and let's just say you hit it at, pretty fast, like 80 kilometers an hour. And this thing is traveling at 80 kilometers an hour, but due to, wind resistance and gravity, maybe not so much gravity, but mainly wind resistance, this thing is going to slow down by the time it gets to, really far away. I think a golf ball is a better example. This thing is going to travel, let's say, about 100 meters. It's going to slow down over that time, okay? And it's going to have wind resistance pushing against it, slowing it down. Same with this, okay? Until eventually it hits the ground, and then it's going to change dramatically. But its speed is slowing. Its acceleration is decreasing. Another one, this is a little bit harder, but might make more sense. Let's say you have a favorite YouTube star that you follow, not this channel. And let's say they've got subscribers going up and 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 up, and they're getting heaps more subs. Okay? Subs and time. The rate at which they're getting subs is increasing. So here they're getting 100 subs a day. Here they're getting, let's say, 500 subs a day. Okay? So it's showing that not only a total increase, but the rate at which they're getting them is increasing. Okay? I hope these examples have kind of helped you understand the idea behind what we're going to be doing. In our next video, we're going to be diving into a little bit more of an explanation, and then our video after that will be a bit more mathematics grind.